So as I told you, we are going to actually put hands-on microscopes, and in order to work with the microscope, you also have to know a little bit about how it magnifies things and what it does to images. So literally, what does it do when you look through it? What is what you're looking at a little bit different, all right? So that's what today's notes are about. All right, so just to review the parts: the ocular lens or eyepiece, the body tube, the nose piece, objectives, stage clips, diaphragm, the light source, the arm, the stage, the coarse adjustment, the fine adjustment, and the base. Now, remember in your notes from yesterday, your coarse adjustment and fine adjustment sat on top of each other, like a wedding cake. I told you there were some different ones. This is a picture of a microscope that has the coarse adjustment and the fine adjustment separate. So some of our microscopes look like this, but again, big knob coarse adjustment, little knob fine adjustment. Now when you're carrying a microscope, which you will be doing, you always put one hand on the arm and one hand underneath the base, and you want to kind of tuck it in close like a baby. So literally you're going to grab the arm, put your hand under the base, and you're going to bring this thing in close to your body to carry it, okay? Tuck it. Y'all, this is going to keep your microscope safe. Now, the reason why we want to keep a microscope safe is if you break one of GMC's microscopes because you're not doing what you're supposed to do, that's going to cost you about $500. That's what it will cost to replace one of these microscopes, around $500. So you want to tuck it in close and keep it safe. If you're doing everything right and you hit a wet spot, hopefully not, or someone accidentally trips you up and that microscope gets broken and you were doing it right, that's a bad accident, okay? It's not your fault. But if you grab a microscope with one hand and you're walking through the room swinging it and it goes slipping out of your hand, you owe GMC $500, and we don't want that to happen. So arm, base, tuck it in tight like a baby, okay? All right. As far as finding the power that you are magnifying a specimen, you're going to calculate it by taking the power of the ocular lens, the eyepiece, and it can be found right here, and you multiply it by the power of the objective lens, which is right here. So our eyepieces are 10x, and our objective lenses can be 4x if it's the low power, 10x if it's the medium power, or 40x if it's the high power. So you got to multiply those together. So you would take the eyepiece times the objective, all right? And so you would get 400x. Go back to that and show you again. 10 times 40, and so this would give you a 400 power of magnification. Got to get them multiplied together. All right, another thing about looking at magnification is the higher you go in magnification, the more detail you can see. Okay, you get all those little details start popping up. You start seeing them. So the higher you go, the more detail you see, but the less of the object you see. So here's an example. At a lower power, 7x, you can see the entire eagle's head and even some sky back behind him. But when you zoom in and go to higher magnification, 10x, you lose all the sky. You lose the edges of the eagle's head. Now all you see is the eagle's face. Now you can see more about his eyes, you can see more about his beak, but you've lost some of this out here, okay? That's called field of view, okay? And so the higher your magnification, the smaller your field of view. So if you were looking at these two images, which image is a higher magnification? This one. The one on the right. This group of cells right here is this group. This one's lower magnification. You can see all this stuff around it. This one is higher magnification. I got a lot more detail going on here, but there's a lot less of the whole picture to see. So more detail, less picture, more picture, less detail. Low magnification, high magnification. All right. And when you go to make a wet mount, which we will be doing, we will review this when we get to that part, but this is just a step-by-step of how to make a wet mount. Make sure you find, you get this slide where you can access it in your notebook. All right, you get a clean slide and cover slip. You're going to put one single drop of water on the slide. So here's your slide, there's your drop of water. All right, then you're going to place the edge of the cover slip just to the side, and then you're going to lower that cover slip down onto the water. All right, and that's going to lock them together. And once they're locked together, you place the slide on the stage. Always start with low power objective. Use that coarse adjustment knob and get it to where you can see it. All right. You might have to move the image, and then you'll rotate that revolving nose piece to go to a different power objective and keep focusing. Okay. Don't use the stage clips when you do a wet mount. Usually making a wet mount, you're going to have to move things around to try to find stuff, and so you don't want those stage clips in your way. All right, those are some of the basics. We will do more with these, and they'll make a little bit more sense, hopefully a lot more sense, as we actually work with slides and our microscopes.